going to be talking about today is, the two most popular low-level assessments that are there in the security testing industry, right? So there is application security testing. It's known by various names. We'll look at those names. And there's also the code side of it, right? There's also that approach that is taken. These are the two most popular ones. There are other ways as well in which security is, testing is conducted or security assessments are done. But in the low-level side of it, these are the two main ways in which assessments are done, right? So yeah, Shravanti, thanks for giving an intro. So I'll not take up much time on that. Rather, I'll just say that I've worked in the AppSec team here in ThoughtWorks India, and what we primarily do is, conduct security assessments, reviews, and ensure that there is secure delivery of applications, and be a part of that. So I have around 7 years of experience in offensive, primarily in offensive, and a little bit of defensive security as well. So which means it's more around exploiting applications and trying to hack them to understand what are the weaknesses that are there in a particular system, be it a network or be it a application, whatever. So with that, let's move on. The agenda, like I said, these are the two things that I was talking about, right? One is the application security testing, which is also known as, VAPT or PT, or there are other names also for that. The other type of testing that we look at is secure code review, right, which is from the code side of it. What kind of problems or what kind of security vulnerabilities can we find out of them? So we'll do a deep dive of sorts to understand what these methodologies are, why do they exist, what happens within them, what are the pros and cons, and what kind of benefit do we realize out of each of these methodologies. And towards the end, we'll try to understand why is it a good idea to mix both these methodologies, right? And when you're trying to do code-assisted security testing. So the agenda overall is that we understand these two methodologies in detail, and then try to understand why is this a better method, when compared to either of these two methods on the top. Lastly, I'll also do a demo where I'll try to show you how security testing with remote debugging is a fantastic idea, in my opinion, and how that can help a security tester, come up with vulnerabilities in an application much faster than the traditional method of just security testing. Now, keep in mind that this talk is going to focus. The perspective that I'm going to give here is more from a penetration tester or a pen tester or a security specialist, because that is my role over here, and that's why I'll speak more from that perspective. If you feel otherwise, if you have something that you feel is not right, please feel free to raise questions or ask if you have any queries during the call itself. So things that I'm not going to cover, for example, is why do we need security? Why do we have security testing and all that? So I'm assuming that we are beyond that. We already know why security testing is required, right? Even if you don't, I just give a quick overview. So security testing, essentially, the purpose is to understand the current state of security. That could be from a network, infra, application, from any perspective, right? And the idea is to have that awareness of where you stand in security, to be able to fix whatever weaknesses you have identified, and then have some level of assurance that this is the kind of security that I have, these are the kind of defenses that I have, and this is how the defense actually is working, right? So for example, if you have a firewall, somebody may claim that as long as you have a firewall, nobody can ever attack you. That is not necessarily true, right? So these kind of assessments and reviews and tests show you what the real picture is of a particular control or of a particular defense mechanism. Now, the scope of security reviews in general or assessments is quite broad, but like I said, again and again, we'll focus on these two low-level assessments only. So this entire talk is more about the low-level assessments. By low-level, what I mean is, we are not looking at the application's architecture or the application's overview, or we are not trying to look at it from a 80,000 feet view. We are rather coming down and trying to understand the intricacies of the application and trying to see what kind of security vulnerabilities that exist in them. So typically, you would find there are these three broad categories in which security testing is generally divided, right? It is generally a black box, gray box, or a white box test, right? So a black box is a situation where you have very little information or the bare minimum amount of information given to a tester. Why is that done? That is done because you are trying to simulate an external attacker or an attacker who has no internal knowledge whatsoever. So he or she is not a part of the organization, does not know the application through and through, and is only a public-facing user. This is typically done for public-facing websites, right, or public-facing applications. So let's say there's an e-commerce site. So the person or the tester will be given a particular URL, right, for that particular application to test, and he or she will not be given anything beyond that. So you do whatever you can as an attacker, or you try to simulate that scenario where an attacker will get as much information from the internet as you as a tester will get. So that is your black box. Problem with that is that it has very little coverage, because whatever you can figure out within that given timeline is all that you can do, right? There's nothing beyond that. And the other thing is, this is more of a dynamic analysis, right? So this is when the application is already up and running. The environment could be prod, could be pre-prod, or could even be staging environment. That's a different discussion altogether. The idea is that it simulates only malicious public-facing users, right? So only those kind of users are trying to be simulated in this black box setting. Under gray box, the thing is, it's a lot more broader now. So when you talk about a gray box assessment, you are saying that you will give the tester all the user roles that exist in that application, and typically we are given two sets of credentials per user role. So if there are 3 user roles, we are given 2 sets of credentials for each. Essentially, we have 6 sets of credentials with us to test. Right? This is in order to understand a little deeper. So here the idea is that you are trying to simulate a malicious internal and public-facing users again. Right? So you will have access to the admin roles, you'll have access to moderator roles, and any intermediary roles that may exist. And also you will try to cover the black box test cases. So obviously gray box, the scope for a gray box test is larger than that of a black box. And this is how it is larger, right? So you have all these roles now, you have all these credentials given to you. You'll have to now test if there is horizontal privilege escalation, vertical privilege escalation. These kind of test cases are typically covered in a gray box environment. Now, black and gray box is where you typically have something called as application security testing done, or security testing done. Whereas white box is slightly different. White box is where you have access to everything. Now, the reason I have this slide in the very beginning is because black, gray, and white applies to not just application security, it applies to infra security testing and those kind of testing as well. But obviously here we are only focused on application security testing. So that's the perspective that I'm talking about over here. And that's why I'm using examples related to application only, and I'm not touching infra side of it over here. Right? So in a white box application security test, I'm given access to the source code, to any architecture diagrams, any information that I need, I'm given access to that. That's how, and that is essentially the activity that is carried out is a code review activity. It is not really a test, right? So it is not a penetration test that we do over here. So that is a typical white box activity for application security. Now, having understood that, let's move on to the actual, application security testing. What does it mean? What really happens in that? And what are some pros and cons and deliverables or outcomes out of a typical application security test? So there are essentially, it is a low-level assessment. I've already mentioned that in the beginning, and it is done. This testing is done only. The only objective is to figure out what kind of security vulnerabilities exist in an application. Right. This again will be divided into 2 bits. So one is vulnerability analysis, which is called VA, and a penetration test, which is called PT. I'll come to that in a bit. But this is typically carried out by security domain specialists. Right? So security testers or security domain specialists are people who essentially specialize, and they have specialized skills and training and knowledge how to carry out security tests only. They do not typically be a part of your development work or infra management and those kind of things. So they only look at the security aspects. So they are expected to understand security through and through, but the other areas are not really something that they can work on. And the idea and the time for this, see, it could reach from a couple of days to a couple of months as well, right? So that depends all on the size and complexity of the application. So coming to the third point, which is VA and PT. So you would maybe have heard this thing that security test is being carried out. It's a application VA PT that is carried out, or sometimes people just call it PT, right? So PT stands for penetration test, VA stands for vulnerability analysis. How are these two different? Vulnerability analysis is essentially where you try to figure out what kind of vulnerabilities even exist in an application, right? So an application can have, let's say, 10 vulnerabilities that exist in it, but you may only be able to exploit 4 of them out of 10. So in a penetration test, the exercise that you essentially carry out is you try to figure out which of these vulnerabilities are actually exploitable, right? And then go ahead and exploit those vulnerabilities and create a POC out of it. So you try to prove to your client or to your customer that these vulnerabilities exist and this is how they can be exploited with a POC, thereby proving that these vulnerabilities actually exist. So a VA activity in general is more broader in nature, right? So if you want more coverage, then you would go with a VA activity only. The problem, however, is that it will not give you a concrete result of whether it is exploitable or not. So if you want a more precise answer of whether something is exploitable, something can be actually used by an attacker, you would go ahead with a PT. So the combination of this thing is called VAPT. Typically, the VA is done by an automated tool. Automated tools, a lot of them exist in the market today. So on the right-hand side, you will find all these brands that are more or less the industry leaders now. So Burp Suite, essentially the Burp Suite Enterprise Edition is what I'm trying to show here. Then there's Acronetics, Micro Focus, Veracode, right? So these are all DAST scanners. We'll come to that in the next, in a couple of slides later, why they call DAST. But these are some brands out there which essentially have VA tools, right? Which is the automated side of it. And then there's a manual side, which is more of a penetration test of it. But what are the phases in a particular engagement of a VAPT or a security test engagement? So the first step that happens is information gathering, right? So the tester has to understand what is the scope, what is the purpose of that application, right? Is it a business, is it a banking application? Is it an e-commerce application? What is the purpose? Because based on that, the test cases are prepared, right? So a financial app will have slightly different test cases from that of a e-commerce application. So once you understand what kind of roles exist, what kind of features of that application is in your scope for testing, it's not always true that you have the entire application for you given to you for testing, right? You may sometimes have only a part of it or only a particular feature that is given to you for testing. Sure. Yeah, Shiva. I'll just come to that. I'll just answer the question in a bit. Okay. So the reason behind scoping and the understanding of the purposes so that you understand what kind of test cases you will have to check against, right? When you actually go ahead and do the test. The second thing is obviously you need to walk through and what is the tech stack, because there again technical vulnerabilities can be specific to a particular language or a particular framework. For example, PHP is known to have a lot of vulnerabilities. So if you know it's a PHP application, you know there are certain PHP specific vulnerabilities that may be present in the application. So you would want to understand what those are and try to take some prepare your test cases again based on that. Walkthrough is required because unless you understand the application, there's no point in you doing a test for it, because you will not then know what is the breadth of a particular feature, what is it used for, who are the likely users of an application of that particular feature, right? So admin users features can be very different from that. I mean, will be very different from that of a normal user or from a moderator. So the idea is to understand those things and then based on that prepare your test cases. The next step obviously is that you will try to understand what are some security sensitive features, something like authentication, authorization, or let's say the entire admin side part of the application. That is going to be very sensitive because that is the juiciest part of an application for an attacker to get their hands on, right? So if you are an administrator, then you are more or less, you have access to everything in the application, and the application in general trusts that particular role the most as compared to any other role. So you inherently get more chances of getting deeper into the application or trying to break more of the application. The idea behind a penetration test, the reason it's called penetration is because you're trying to get in as deep as possible, right? You're trying to simulate an attacker. Now, an attacker, at least a good attacker, would want to get into the application, stay there for a long time undetected, and then come back whenever he or she wants to come back to that application or come back to that server, and then do whatever that is they want to do. If they want to steal data, if they want to set up a keylogger, if they want to put up a sniffer, whatever that objective may be for an attacker, the idea is that they want to stay, get inside as deep as possible, stay there stealthily, and then pivot from that application to other applications inside the organization. Typically, that's what an attacker would want to do. So it's very important that you figure out what the sensitive areas or sensitive features are in an application, at least security sensitive, and then focus more on those, right? If you have a limited amount of time, you would really want to focus more on the sensitive areas and see if there are bugs over there. The last bit on information gathering is your spidering. Essentially, when you get the URL and you're allowed to go, I mean, you're given the explicit authority to go ahead and test it, you would want to spider the application and try to figure out what are the endpoints, what are the pages that exist over there that are reachable from the front end or from the UI side of it, right? And that is because you want to explore every bit. So the idea of a penetration test is to look at all possible avenues that an attacker can have, and then try to exploit them, check if those are exploitable or not. That is what a penetration test essentially means. So Shiva, to answer your question, why aren't all vulnerabilities exploitable? So there are two things to consider here. One thing is that all publicly known vulnerabilities may not have a publicly known exploit associated with that. So while there are, every exploit that exists, publicly known exploit that exists, will have a CVE ID given to it. CVE stands for Common Vulnerabilities and Exposures, which essentially states that this particular product or this particular technology has a particular vulnerability within it. Right? So whenever some application tries to use a component, let's say MySQL, or let's say, for example, Log4j, right? This thing that's been making a lot of noise recently. So there's a CVE ID now associated with that. Now, Log4j may or may not be exploitable because there may not be any publicly known exploits. Maybe there is. I'm not saying there's not, but if that is the case, then it becomes very difficult for tester to go ahead and exploit it. So that's one reason why all vulnerabilities are not exploitable. The other reason is a particular vulnerability may work only if certain scenarios are in a particular if they're placed in a certain way. Only then they'll be actually exploitable, not without that. So those are some reasons why all vulnerabilities are not really exploitable all the time. I hope that answers your question. All right, moving on. So the next phase of a penetration test or a VAPT for an application is doing the vulnerability analysis. So like I said, VA is when you want to cover the breadth of the application and or your scope, whatever that might be, and you want to figure out how many possible avenues are there, for you to attack or exploit. So typically that's when you use a DAST scan, right? So DAST is something, DAST essentially stands for Dynamic Application Security Testing. What that is we'll come to that in a bit. But the gist of it is that it is a tool which tries to scan the application for vulnerabilities. How does it do that? It already has a database of exploits, of known exploits, or a database of vulnerabilities that are known publicly, and it tries to check for the presence of those exploits or vulnerabilities in the application that is being tested against, right? Based on which it comes up with its own results and then gives it to you, right, in the form of a report. Now, all of them may not be exploitable. We already know that because this is a VA, but it at least gives you a starting point, right? This is how you can start looking at the application or try to attack the application. The other bit in a VA is getting a feel of the application. Now, this may seem trivial, but it is not. And that's because unless you really understand what the flow of the application is, you're doing a very, a very incomplete test is what I'll say. Because once you get a hang or a feel of what the application is, what the UI feels like, how the server responds to certain queries and all that, that's how you essentially will tweak or modify your test cases to ensure that you're able to cover much more. So that is the VA part of it, right? Then moving on to the exploitation part. So there are 5 phases. I'll just cover this quickly as well. Here is where the fun part is, right? So here is where the most juiciest part is, where you get to exploit these vulnerabilities. So one source for vulnerabilities for you as a tester is the DAST scan report, right? If you have done that, if you have that report with you, great, that's the starting point for you. But apart from that, also, the moment you look at the application, the moment you run, enter certain values as in the parameters, you begin to understand, you begin to see what is the reaction that, how does the server respond back to you, based on which you will now try to exploit, or you will now try to use payloads to confirm once and for all whether there's a vulnerability or not. For example, I'll give you XSS, right? So when there's a search function in an application, if I search for something like, a tennis racket, let's say, the search term typically is also reflected back onto the same page where the search results are displayed. That is like at least that used to be a very common place for XSS vulnerabilities. Right, so I would check over there whether if I send any special characters or HTML characters, if they are being sanitized or not, are they being encoded in HTML format or any other format for that matter. So this is how I'll test for application vulnerabilities in a particular application, apart from what the VA or the dash scan report has given me. But the point is that I exploit it in a way that I'm able to prove it tomorrow, right? So I create a POC, a proof of concept of that particular exploit. The other interesting thing is I try to chain exploits. Now, what exploit chaining essentially means is that there may be a vulnerability of excesses, there may be a vulnerability of another nature altogether different, right? And there may be two independent vulnerabilities. But if I'm a good and experienced penetration tester, I'll know how to chain these two together in such a way such that the impact of it becomes much larger than any of these individual vulnerabilities. Right. So on their own, these individual vulnerabilities may not have a lot of impact in the application, right? So it may seem very trivial that there's nothing much that has happened. But if you're able to chain it in the right way, you might come up with a much more powerful attack vector for that malicious user may use. So this is the thing that you do in an exploitation phase. The next bit is post exploitation. Once you have covered all the vulnerabilities and you know that 5 out of 20 are exploitable or whatever that number may be, then you essentially do a cleanup of sort. What that means is you'll want to clean up any malicious artifacts. For example, if there's a file upload functionality, you would have tried to upload a variety of files into it. So what should have allowed you maybe to only upload an image, okay, of your profile picture or whatever. You may have uploaded a binary file, an exe file, or a shell script or something like that. Essentially, you're trying to gain some level of execution on the server in the backend. So in that process, there's a lot of artifacts that we send, during these tests. And the cleanup of that is very important because otherwise these artifacts will remain on the server. And tomorrow, if it gets compromised via some other source, it is going to only help the attacker that they already have all these good stuff already on them. If you have successfully got any shells, right, a reverse connect shell, or you've been able to compromise a particular server, you would want to go ahead and do a cleanup of that as well, so that tomorrow nobody else is able to use that same exploit again to get a shell of that particular session. Any configuration changes that you have made, let's say as an administrator, you've got access, and as an administrator, you've made certain changes to the application at a configuration level so that it helps you in your testing and attack. So those kind of things have to be reverted back, right? So that is the post-exploitation stage. Finally, you come to the reporting bit, which is essentially you just do a triage, right? Triaging essentially is that you give a severity to each of these vulnerabilities that you found out. So there are 5 vulnerabilities that you've been able to exploit. You now give it a ranking. You define the impact of it. You define the recommendation for it, right? And obviously, you will also explain the POC that is given. So this is a typical life cycle, right, of a particular test. This is what you do, and then you come back to the information stage again for the next application. Any questions here, folks, before I move on? All right. So now I did mention about you using a DAST scanner, right? So this is your dynamic application security testing, or it's simply a application security scanner is also something that you can call it. But the idea is that it has its own database of vulnerabilities and exploit that it uses against a particular application that you ask the scanner to go ahead and scan for. What are the pros of that? It is definitely very fast. So what some person might take maybe a week to do, this can do maybe within an hour, right? It can be quite fast, actually, to be honest. And all that also depends on which environment is it that the scanner is hosted on and the application is hosted on. If it is over the internet, it is generally a little slower. If there is a firewall, if there's a rate limiter in between, it will obviously slow down stuff. But typically in internal environments, it can be very quick, these scans. Now, these are typically language independent, so it doesn't matter whether your application is written in Java or Node.js or whatever the case might be. Regardless, it is going to do a scan based on the input and the response. So it is going to send malicious input in the requests, right? That it is of that application, and based on the response that it receives, it tries to gauge whether or not that particular vulnerability exists or a particular security weakness exists or not. That's like the most basic way of looking at how a security scanner works. This definitely helps in security automation, because if you have a dash scanner in your pipeline, although it will run only after the application is built and everything, it is still something of a early feedback, essentially, rather than wait for a manual pen tester to go ahead and give his or her results at the end of the test. There is much wider coverage because it is, since it is an automated scan, the what typically scanners do is that they have a spidering phase, right? So where they try to collect all possible links that are there in an application and then run that entire set of tests again all these endpoints. So the coverage is much wider than what typically a human can do at the same time. The other advantage is that based on the database that it uses to figure out what the vulnerabilities are, it is also going to give you results that are tried because it already knows what the what do you say the results. I mean, what the vulnerabilities are, what the exploits are, and that's how it comes back. If you remember this, the black box and gray box side of it, it essentially covers both of them. Right? So that is also another advantage. There are some problems though. A dashed scanner or a security scanner cannot figure out if there are any business logic issues. You need a human for that, or you need to very clearly define it in the scanner. Otherwise, the scanner will not be able to figure out if there's such a test case even, right, for it to test. Typically, these scanners give a lot of false positives as well. So that is another drawback that they have. They do not cover the white box side of it, right? This particular scanner does not do a code level assessment. So it needs a URL or an endpoint, and only then it is able to do a particular test. So there's no point in giving it source code. And the recommendations are generally, they are generic in nature, right? So they're not specific to the application. So if they just tell you that for XSS, encode the response back whenever you do something like output encoding, that's the kind of response that you will get from a scanner, right? These are your recommendations. So as opposed to something that is manual in nature. So now on the right hand side, the penetration test for application is done by a human being typically. So these have their own sets of pros and cons. One thing which is pretty obvious is that these they are more time intensive, right? So one con is that the manual bit is going to take a lot of time as opposed to 1-2 hours of dash scanner. It requires somebody who understands security, who understands security testing pretty well to be able to do a good test, right? So that is another thing that you need domain specific skill sets. Pros, there are a lot of them. So your POCs that come out in the report is actually things that you can these are actionable items, right? Because they are exploitable issues. You know that they exist, and you know what the POC looks like, so you know what to go and fix, go back and fix. The coverage is a lot better than the coverage over here. So this is more wider nature. This is more in-depth nature, right? So the depth over here can be quite a lot. So for example, if there's a particular payment logic that that is in scope, you can try to bypass that payment or try to increase or decrease the payment value and do all these kind of things with a manual test approach, not really with an automated approach, unless you've customized. So logical issues are addressed. Like I said, exploit chaining also something that it covers. Manual typically covers black, gray, and white box as well, right? So, and the last bit and one of the most important things is that you get customized recommendations in the report. So because a human has tested and knows what really the vulnerability is, they can also tell you what the fixes are, a lot more customized than what a tool is going to give you. So they tell you exactly what is it that you need to do at quite a in quite a detail. They can give you, or what is it that you need to do as part of your recommendations to fix that particular security bug or issue. So now we've understood what is, sorry, somebody has a question. Okay, I guess not. So now that we have understood what the what security test application penetration test means, we know what the typical outcomes are, we know what the automated versus manual, what that looks like. So the next natural question is, so why would you even get it done, right? So why spend that money, time, effort for getting a security test done? So one thing is, one of the most obvious things is that you would want to know about your application vulnerabilities before any attacker does. Right? By the time an attacker knows about your application vulnerabilities, it's already too late. They would have already exploited it. They would have already gotten whatever they needed to get from that attack. So you don't want to be in a situation where it is reactive in nature, right? So after an attack, you don't want to know that, okay, this is how a particular attack can be done. Let me now go and fix it, because by the time it is a little too late. The second thing is that a secure product will definitely lead to more client confidence and a better reputation in the market. So if there is a product that you have created and that has been compromised, it is going to be a long-lasting hit on your reputation, because people are always going to remember that particular tool and who's the creator of that particular tool, or of that particular product, and it's going to be quite long lasting. It's very difficult to come back to that reputation where people have confidence in your particular product or your projects. So lastly, there is always almost every time there's a compliance requirement to some statutory or regulatory requirements. There may also be legal requirements, right? So these are some reasons why you have to get your application tested once every year, once every half yearly or quarterly, whatever the case might be. Right? So typically PCI DSS requires that you get your application tested by a third-party vendor. Right? You cannot test your own application. You'll have to get it assessed by a third-party vendor. So those are some requirements that are there from the compliance side of it to ensure that there is assurance that is given by a third party. So while these are the reasons to get it tested, in general, with application security testing, there are some pros and cons as well. Now, this is not specific to manual or automated. The assumption here is that you have done manual and automated both together, and still there are some pros and cons. So this kind of approach gives a good coverage, no doubt. It is also a very popular type of security testing. Why have I mentioned this? I mentioned this because it is easier to sell something which is already popular in the market. So if you go to a client and tell them that, we have, either you tell them that, we can offer such services to you that you can, will test the security of your application, or tell them that we have created a product which has already gone through, a couple of rounds of security testing internally. That in itself will give a boost to your, to your sales or to whatever it is that you're trying to achieve with the customer or to the client. The other thing is that this typically leads to a reproducible POC with very little or no false positives at all. So I'm talking about a test where you've done your dash scan, you've done the VA bit, you've also done the manual penetration test bit, and you're giving out a final report, right, out of an application VAPT. So you've done that dash, the automated and manual both aspects of it. So like we saw on manual side of it, the logic issues are going to be assessed because they'll be checked for security vulnerabilities. You will also know if there are any exploit chaining that can happen. So exploit chaining typically means is that you have two otherwise independent vulnerabilities which can be chained together to become a much more powerful attack vector. And finally, you will be able to cover black and gray box. Actually, in the previous slide, I think it was written as black, gray, and white, which is not the case. You cannot cover white boxes in this kind of testing. It's only black and gray. However, there are some problems as well, right? So you are going to bombard the application with a lot of payloads. Typically in your dash scan, there is a huge amount of payloads that are sent. So what we as testers try to do is we try to rate limit or try to throttle those scans so that it doesn't bring down the application. Because if it is in prod, then there's always the fear of the application going down. If it is in a lower environment, then there's a fear of other people who are working on the same environment, they'll not be able to work because it will crash the application. Right? So that's the other problem. So it has to be throttled, and only then it can be considered for scanning. Now it is time intensive. So for example, the manual side of it is going to take time because a tester will have to go through these pages, application, the features, try to figure out what is exploitable, what is not. It takes, a day or two for the tester to even get a feel or hang of the application. So it's not that on day one testing starts. Day one, it actually does take time for a human to get familiarized with the application, and only then you actually, the real testing happens. So this is a time intensive activity. I already mentioned this that you need security domain specific skill set. So you need to know what security testing is about. How do you go about doing it efficiently? And once you've got that training, once you've got that experience with you, only then will you end up doing effective security testing. Simply trying to Google search for what are the ways in which you can do testing and all will not work really. You'll be able to do for a couple of test cases, but you'll not really give it the the justice that is required for a security test. The other problem is that this typically happens in the later part of SDLC, right? So it happens once your application is more ready or more built, and once it is there, only then can you even start doing it. So if somebody has a question, please go ahead or use the chat. Okay, all right. So like I said, it can only be done in the later part of the SDLC. And then the last part is that it needs a stable environment for precision. Unless you give the tester a stable environment, they will not be able to run and verify test cases. Because if the environment is unstable and if the responses keep fluctuating or changing, then it becomes very difficult to determine whether a particular vulnerability exists or not. All right. So this is all about security testing, folks. If there is any question in this section, please let me know. The next section is about code review, right? Secure code review. Before we move on to that, if there are any questions, please feel free to ask. Unmute yourself and ask the question. All right, so I'm assuming there are no questions then. All right, moving on to secure code review. So what we have seen all this while is how a tester, or a typical security pen tester or penetration tester looks at application testing and how do they carry it out, and all that good stuff. Now we look at more of the code side of it, right? So this is typically a lot more developer friendly, because developers are a lot, obviously since they have developed it, they are very comfortable with the code and they are very comfortable with those aspects. But on the same, on the other hand, the problem is security testers typically are not very comfortable with reading code and doing code reviews and all that. So this is something which is simply there in the industry, and there are a very few. This is quite a small group of people who are very comfortable with code and with testing. Right? That's not really a very common group of people that I've come across, at least. So this is the challenge. On one hand, you have security testers who understand security very well, who understand how to exploit it, how an attacker would actually exploit it. On the other hand, you have developers who are doing the best to come up with a more secure application. But there are sometimes there are more advanced methods that are available, so they may not be aware of the latest trends in security attacks and all that. So that's another reason why they are not able to maybe come up with a 100% secure product. So looking at secure code review, right? This essentially is an activity where the focus is all around the application source code. So here you do not want to touch the application URL and all that. Typically, no, you wouldn't do that. Rather, your focus is almost entirely around the code of that particular application, and you hunt for vulnerabilities within that. This is typically carried out by a security domain specialist again, but who can also read and understand code. So this is not a very a common group of skills that we've seen. So typically if there are some security oriented developers, then that's fantastic, because they'll understand what they're trying to look for, right, in a secure code review. This again can range from a couple of days to a few months. So for example, if it's a 1 or 2 pages of code, if it's only a small feature that you're trying to do a review of, then yes, it need not take a lot of time. But if it's a huge and complex application and that has to be reviewed, it'll take a lot of time. Now, why I'm saying this is because this review is typically not done by the developer who's worked on it, right? So it is done by somebody else who's stepping in and trying to assess the state of security within that code. And it takes a lot of time for them, because they have to first get a hang of the code, understand the structure of the folders that are there, understand how the application behaves, and only then begin to understand what to even look for in that particular application. So for a so folks, like I said in the beginning, the perspective I'm trying to give over here is a lot more from a security tester perspective, because I'm from that background, right? So what I'm trying to say is that security code review is typically considered to be more painful, or something that is more avoided from a security testing standpoint, for these reasons that since they are not from a development background, they typically are not too comfortable touching this. So that's the reason why this is a lot less popular compared to security testing that is done. Sorry, I'm just reading the chat here. Yeah, Gaurav. So your question is about secure code review, I'm assuming, right?
Yes, Sujay.
Got it. So the idea is that you have it in the pipeline. So if you have something like a SAST scanner in the pipeline, right, there's at least one way to ensure that this is scanned on a more regular basis. Right? So this is one way to do it, but apart from that, there has to be a manual code review also that happens every now and then. For example, if you can involve somebody in the design stage or in the requirement stage, that itself is one place in which you can start adding people. But apart from that, also a manual code review has to happen every now and then. If you ask the folks who are developing the application to do a review, it is not going to give out great results, because they have a bias, right? Because they are the ones who have developed the application, so they have a certain bias towards the application, and that it turns out that that doesn't give out great results. So that's why you need somebody with a fresh perspective or a fresh set of eyes to come and take a look at a code for security vulnerabilities.
Is there a recommendation on how frequently this manual code review should be done? Because
So,
given that you mentioned it may take a couple of days or sometimes more as well.
correct. You're right. So the idea is that you obviously hire or get somebody who understands code and testing as well. And once you've done that, then the frequency depends on the kind of application that you're trying to build. So if it is a high risk application like banking applications and all that, they typically do a code review for any sensitive feature that they're trying to add or modify. But enhancement features or UI enhancements and all are typically not covered. So that frequency depends on the kind of application, the kind of environment in which this application is being hosted, and those kind of things.
Okay. Thank you.
Sure. For the other question, Sarkan, which tool are you using for this code review? Right. So for code review, the leader, in my opinion, right now is checkmarks. It's been there for quite some time, and it is still, almost on the top over there. But Coverity by Synopsys and Veracode are not far behind. Right. We've seen that they also give pretty good results. So these are some SAST tool scanners. So you remember DAST from the previous section. This is SAST. SAST stands for Static Application Security Testing. So this is static analysis because the application is not really running, so it is not dynamic in nature, and that is why this is called a SAST tool. And these are some brands on the right-hand side, which are, you could say, the world leaders of sort. Unfortunately, I've not come across any free or open source tool that does a good job. I've heard a lot of people say that they use SonarQube in their pipelines as a SAST tool. I don't think that is a SAST tool at all. It is a good linting tool probably, but it is not really a good SAST tool. There are some security vulnerabilities it does report and try to identify. That's there. I get it. There's a plugin for that, but it is not really a dedicated SAST tool because a dedicated SAST tool does a lot more than just give you those kind of vulnerabilities. Okay, so moving on, I'll just quickly try to cover these key phases because they are very similar to the ones we saw previously. I'll just highlight the differences, right? So information gathering is still the same. You figure out the scope, you get a walkthrough, understand the tech stack, and do all that. Static code analysis is where you use this particular SAST scanning tool. How that happens is typically you point it either to a repo that it has access to, or you upload the zip file of that particular entire code base, right? And then apart from that, you as a manual code reviewer will try to understand the structure of the folder, in which the code has been written. There are certain styles in which developers write code or develop applications. So you try to understand which style or which methodology has the developer used, and then you'll see that similar pattern being followed everywhere. Hopefully, if it is a well-developed application. So once you get a hang of the pattern that the developer has or developers have used, then it becomes easier because you will see a similar pattern going around the rest of the folder structure. The other bit is that there is this source to sink analysis, right? So this is again the juiciest part in the test over here. This is essentially you try to understand where is it that an attacker can insert inputs. This could be the front end. This may be some other way for it as well. What I'm trying to say is the attacker might be able to insert payloads or malicious data or whatever or scripts via the UI, but there are also possibilities where an application depends on the database of another application, right? So that also can be an untrusted source of data for that application. So a source is essentially any point from where an attacker is able to inject something malicious. And a sink is where this malicious data or script or whatever attack is happening goes and gets executed. So the process of figuring out whether a input actually goes through certain functions and methods and whatnot and can get executed in a malicious way is what is called as taint analysis, at least in the world of SAST or code review, secure code review. Right. So taint analysis is what we as humans also use, and even the SAST tools use as well. Apart from that, there are also SCA analysis. Now, SCA stands for Software Composition Analysis, which is essentially looking at the open source third-party libraries that the application uses, right, as dependencies, and understand whether they in themselves have any vulnerabilities on them or not. This is another example of how certain vulnerabilities may not be exploitable, right? The idea is that even if there are dependencies which are third-party and open source and have known vulnerabilities, the way they are being used in an application need not mean that they are exploitable in that particular way in which the vulnerability is known to be exploitable. So that can be different. So that is another example of how that may be the case. So after you've done all this, after you've manually reviewed the security sensitive area like authentication, login, password reset, that is one very common place that we found vulnerabilities, right? How the logic behind password reset, the kind of parameters that you send to the reset link, those things we have found they can be manipulated in a way that you can reset anybody else's password. So at least I personally have found that to be a very overlooked area. People don't really give a lot of thought of how passwords are reset. So those are places where you would manually want to go through it, because a SAST tool will not be able to understand what kind of logic is at fault over there, right? So that is a place that you would want to manually spend some time on. So the challenge over here, folks, is that for a person who's otherwise a security tester and is a security domain specialist, he or she may not have the know-how to figure out what is it that that piece of code does or the code snippet does really. So that really is the challenge that I'm trying to bring out over here, and that's another reason why this whole activity may not be as popular as security testing. Okay, so moving on. So the next step essentially is where you figure out what the recommendation or the mitigation strategies are. For example, a best place to fix. So if you have an excessive vulnerability, there may be a common point where you put in some sort of output encoding, which can serve as a purpose for which can fix the vulnerability for a variety of components in the application or a variety of places in the application. Or for example, if if you use let's say, for example, you use a library or a framework to do that encoding or that kind of mitigation for you. That's only one place that you need to fix it, and everywhere else you need to just point it towards that particular library or utilize that methods in the library. So those are ways those are some mitigation strategies that we try to give in our report so that it becomes easier to fix. The other thing is that because this is a code review, I can, as a tester or I can as a reviewer, tell you where do you need to go and fix these issues. I'll give you the file, I'll give you the file location, I'll give the line number in that file which is affected, so that it becomes like a very easy task for you to go and just fix that particular instance or number of instances, whatever the case might be. Finally, in reporting, which is very similar to the other reporting that we saw, you essentially tried these exploitable issues. So a SAST scanner is going to give you again a ton of issues, right? So you could have something like 500 vulnerabilities, out of which maybe just 30 of them are exploitable. In my experience, I've found SAST scanners to give a higher rate of false positives if they're not configured properly. If you leave it in it, if you use a SAST scanner in its default state, it is going to give you a lot of false positives. That is something I've seen time and again happen. But the idea is that you try to have a lot more coverage, right? So we'll just quickly run through because I think we are short on time. So here, folks, automated and manual, right? So automated essentially is the SAST tool that I've been talking about. So it is again like DAST, it is quite fast, right? And it gives early feedback. Right, so this is the moment the developer or somebody has pushed the code, you can have a SAST tool run on that particular snippet or that particular feature, and then it can give you a what do you call this? It's essentially called sorry, I just forgot. There's a name for this particular thing where it only scans a particular section of the code, not the entire code piece. So you can have that scan done early, and then that feedback comes early, so that you rectify this problem much earlier rather than it going to to the build stage and then going for testing elsewhere down the pipeline. So this again helps automation of security, which in general is going to help with the shift left concept, right? The other part is that so there are cons. The cons are that your tool should be able to understand that language, right? So new languages, something like Rust, I'm not sure how many tools really can handle Rust properly, although they may claim that they do know how to scan for it. There may be issues with the legitimacy of that particular thing, of that claim. They cannot by design assess business logic issues. A SAST scanner will never understand what it is, at least not in today's age. Maybe down the line in the future it does. And like I mentioned, it contains a lot of false positives, right? So there is that big con with a SAST tool. With a manual approach, the pros are that there are very few false positives because you have manually gone and figured out whether there is a vulnerability at all or not. The coverage is much better because you are looking at all other interfaces. You can essentially have all the other files handy, which are linked to a particular source and sink, right? So you can get that. Now, this is given that you have access to all the necessary files that are required. If you're only given a particular section of the code and you're asked to do a code review, there are a lot of assumptions you will have to make as a reviewer because you don't have access to the rest of the code, right? So the application may integrate with so many other services or so many other applications. If you don't know how they react and give you back information, it becomes, you'll have to just assume the worst case and assume that it is giving you untrusted data, right? And based on that, give you a report. So exploit chaining possibilities are a lot better checked in a manual approach. Like I mentioned earlier, it is extremely time sensitive. This takes a lot of, time intensive rather, sorry. So it takes a lot of time, takes a lot of effort as well. So that's why this is a little slow in nature if it is a purely manual approach that you're talking about. Lastly, like I've already mentioned, it requires you to have that development knowledge or, understand what is it that the code written over there actually does. At the same time, you need to have security domain specific skill sets because otherwise you'll not know whether something is exploitable really or not. Right? So these are some pros and cons of automated and manual approaches. Folks, any questions still here?
Hey, Sujoy, I think there are some questions on chat. Do you want to look at it or now or at the end?
We are actually, oh yeah, sure. Let me just cover this one question. So more of question. Are all the projects being reviewed for security team currently in ThoughtWorks? Do we have a Okay, so you see, as a security specialist myself, I would say, I would recommend that all projects do get reviewed. But unfortunately, currently that's not happening at the moment. So we do have, at least in India, we have the SecChamp program where we try to ensure that there's at least one SecChamp from a particular account, right? If not multiple. So what we do is we try to talk to these SecChamps on a weekly basis. We have catch-ups with them, try to have knowledge sharing sessions, try to do threat modeling sessions with these people so that they are more aware now of what kind of security issues exist, what kind of security scenarios exist, and how to look at it from a security perspective. But we don't have a mandate yet that every project in ThoughtWorks has to go via a security team, or for a sign off of any sort. That's not there at the moment. The idea is to decentralize the security thing, right? The thing that we're trying to do here is BSI, build security in, with the objective that people are empowered with security. So I don't think every developer will have will be an expert in security or will have all these skill sets that a specialist may have. But the idea is not that they have all these skill sets, right? The idea is that they just have enough awareness that these writing dynamic queries for SQL, for example, is a bad idea. That much awareness, if it is there, then that itself is a change in itself. But expecting that a developer will have all the expert knowledge about security, I don't think that is fair on them either.
Okay.
So yeah.
But the dependency would still be there on security team, right? Because given that you have so many projects in ThoughtWorks, and you also mentioned that a lot of these things needs security expert.
Correct. Yeah. So there is the dependency. The idea is to reduce the dependency, and B, when it does come for testing, it should not have a lot of vulnerabilities to begin with. So if you already have a SaaS tool, if you have other security automation tools in the pipeline, a lot of these vulnerabilities are already taken care of. Okay. So what then comes as a result for testing is not much, to be honest, then, because then all the things are already taken care of, and we don't have a lot of test cases to.
Makes sense.
So just a quick look at why you should get this application's code reviewed. I think it's pretty obvious. There are some opaque security vulnerabilities that a testing activity will not be able to look at, right? So for example, if there are some internal and deep logic issues, business logic, or security logic issues, then those are typically skipped because a tester looking at the UI or the application's URL will not be able to figure out, in most cases at least, whether there's a vulnerability in that or not. The second point is, I think, it's the same as the previous thing, right? A secure product will lead to more repetition and better confidence. That's fine. But the other thing is that this adheres to the concept of shift left. So this helps in understanding, or this helps really in gathering, or rather, in reinforcing that idea of shift left, where you get feedback as early as possible to the developer so that they can bring about that change or make those fixes before there's a build that happens on that particular application. So that's the idea. Like we saw previously, there are some pros and cons. So I'll again quickly try to touch upon them. Earlier feedback, it can be these things can be touched upon earlier in the SDLC. That is great. security sensitive logic flaws are assessed. Now, this is a combination of automatic and manual approach, right, of code review. That's where these pros and cons are. They're not specific to automatic or manual. Sorry. Vulnerabilities which are specific to file and line numbers are essentially sent in the report. So the report will tell you which file number is affected, and it becomes a lot more easier now as a developer for you to go and fix an issue, rather than in a security test where I just tell you that there is excess present in this particular page. So you have to figure out which line number is that, where is it getting affected, what are the points to be touched by you for fixing. There are some cons as usual. So this depends on the language that is being used. So the skill set, the person who's reviewing the code should know what, for example, Golang or Rustlang or any other language for that matter, or something like Java or .NET. They should have some familiarity with that language before they do a review. Otherwise, it becomes sort of meaningless. You need access to the source code, folks. So this is a problem because many clients do not give access to the source code. They are very scared of the fact that this will get stolen or this will get, it will get leaked somehow, and then they prefer not to give the source code. Rather, they'll give you a URL to that particular application and ask you to go ahead and do your test, which is going back to your security testing. That's another reason why it is so popular, or rather, secure code review is not as popular, right? Because product companies, for example, they do not want to really give out their code to third-party assessors or vendors for security code reviews. Finally, that's the reason why it is not a very popular type. The other reason, like I mentioned, is that you need that development background or the development knowledge and understanding, along with security-specific domain skill sets. Only then you'll do a fair job of this code review. Coming to the main bit of the entire session is, what is code-assisted security testing? Right. Now, the idea behind this is that you are doing an activity where you have access to the application, dynamic application, that is the URL, and you also have access to the source code. So what happens over here is that I, as a tester, will now bombard the application with unnecessary exploits and payloads. Rather, I would look at the code and try to figure out where is it that I have to attack. If I just give an application, you as a tester will need to bombard the application with a lot of payloads, right? Try this payload, then try the next one, then try the next one. Try to look at the response of the application is giving. This is a very time-intensive process. Rather, if I give you the code, and if you know how to read the code, you know how to attack the application a lot simpler than just simply blindly hitting the application with a series of payloads. So that's why this is such a beautiful approach, where it is code-assisted application security testing and not just plain application security testing. The title is wrong here. Sorry for that. But yeah, this is again carried out by a security domain specialist, but with the knowledge of development or the code that is written. So this is a mix of white and gray box testing, right? So this is where you have complete transparency. So I'll just skip. This is actually just a repeat, so I'm not touching this right now. But yeah, this is what I'm trying to get at. So this takes the best of both worlds of secure code review as well as normal penetration testing or application VAPT. Right? This allows for a lot of efficient and transparent testing. Efficiency, I already told you, you don't need to fire 100 payloads or 1,000 payloads even. Rather, just look at the code, look at what is applicable for that particular test case, and use only those specific payloads. You don't have to go beyond that. So a lot of test cases will be done a lot more faster this way. But then there are some pros and cons with this as well. Pros is that it has very good coverage compared to the individual types given before. These POCs are reproducible, so those things are also given at the end of it as a deliverable. This covers white, black, and gray box, right? So all these types of approaches are anyways covered in this thing as well. Apart from that, your logic issues are also covered, expert chaining is also covered. The con is that it is time intensive. You need access to the source code. You need development and security testing, that know-how, and you need a stable environment for precise results essentially. So these cons are more or less just a repetition of what we've seen earlier. Now, there are some scenarios that I wanted to tell you why this is a better approach, and that is something like, if there are any internal logic flaws that are not apparent from the server's response or the way the application behaves. So here is where what happens is that I, as an attacker, will try to figure out if I'm only given the URL, whether it is behaving in a funny way or not. If I, put a payload for blind SQL injection. Blind SQL injections payload, the attack by definition says that it does not give you any kind of output which can be directly used by you to determine whether the attack is successful or not. Similarly, there are many other such kind of attacks. Insecure deserialization is also a complex attack. Second order attacks, second order SQL, second order XSS. There are a variety of second order attacks. File upload vulnerabilities, for example, you will spend a lot of time in trying to upload files that trying to bypass the mechanism that is back there. Rather, if you have the code with you, right, and let's say in an IDE somewhere, and you're also testing the application, it's then and there you can figure out what is the code that is trying to defend the application, and then try to break that to ensure that you can that you can attack, right? So there are some security misconfigurations which may not be apparent from the UI, but if you take a look at the configuration files, you should be able to figure out whether these are a problem or not. So for example, if you have your access to php.ini or any let's say Node.js configuration files or Python configuration files, those itself will tell you whether there's a security problem or vulnerability that exists of that nature, that is misconfiguration nature. So in fact, most issues are a lot more easier, folks, when you just have the access to the application code on the other screen, and on one screen, you're simply testing that particular application, right? So life becomes a lot more simpler. The only catch over here is that the person who's doing the test and the review should have the know-how to do it, right? They should be able to read that code. They should also be able to test the security or perform security test of an application. Once you have these two as a combination with one person, then they are able to do this in a lot more efficient manner. I personally have found issues that were otherwise not very apparent in the application, and only because I went through the application code, I found that these possibilities do exist. So that is something that I myself have seen happening. There's another thing which is slightly better than this as well, that is remote debugging. So if you don't know what remote debugging is, it is essentially a way in which an application can be set up to run, where you can hook onto the remote debugging port of it and try to set up breakpoints on your local system's code base. So on your local system, or let's say in an IDE like VS Code, we'll have a remote debugging setup such that it goes and hooks onto the application that is hosted elsewhere. This obviously, you need access to that particular debugging port and whatnot. But the beauty of it is that you can essentially set up breakpoints on your screen, test the application on the other screen, and actually see how the application behaves in real time, which is fantastic, because most testers struggle to, at least most security testers struggle a lot to figure out what is it that the application is doing with my payload. Is it getting processed? Is it not? So there's a lot of effort that is put in that. A lot of this effort can be eliminated if you can have a real-time view into the application, which is what remote debugging allows you to do. So you can set up breakpoints at a particular point where you feel there is some validation, and that validation is something you're trying to bypass. That can happen a lot more efficiently and beautifully if you can have a remote debugging element, right? So like I said, this takes it definitely to the next level. Your tester can essentially set up breakpoints on the IDE while testing for vulnerabilities. It gives fantastic visibility into how the application behaves internally, right? When a particular exploit payload is sent. So I have seen this happening during testing, that I'm sending a number of payloads, but then nothing is happening. So, but then if I have remote debugging enabled, right, I can actually see the values of the particular variables which that particular function or that method is trying to use, and what is the kind of validation that is happening over there. Because like I said, I'm not an expert in code, so I'm not really truly understand what is happening with my payload. So even if I have access to the code, I may make some assumptions that, okay, this line number does this, that line number does that. Hence, maybe my payload should be modified in a certain way. But if I have a real-time view, I can actually pause, hit a breakpoint, look at the variables, or write a watch statement, watch expression for the variable that I'm interested in, see how is it that the application deals with or parses my exploit payload, right? Or how the attacks that I'm trying to perform. So that, folks, essentially is the beauty of having remote debugging enabled when you're doing a pen test or a security test rather. So it's not just a pen test, it becomes a code review, it becomes a security test, and it becomes a lot more efficient now. So the coverage is the best in this type of approach, in my opinion. This is not very popular though, because it takes a little more time maybe than a traditional test, because but then you also save time on trying to bombard with payloads and trying to see what the response is. So there's that balance anyways that comes with. However, it is very efficient, right? Because you're not throwing unnecessary payloads, you're not throwing unnecessary exploit or doing unnecessary attacks on it. Rather, you know exactly what is it that you want to attack and exactly what is the response that you're trying to, you should be expecting. Very little scope for assumptions because you ultimately have to come up with a POC for this. So in a code review, there's a lot of assumption that you'll have to make, right? Because you may not have the entire application's code base given to you. You might not have the dependence or some other dependence, but the other integrations, those applications may not be given to you in scope. Whereas in a live environment that you're testing on, those integrations are already there, right? It's just that you have the code for the particular application on your IDE setting over there. So a lot less assumptions have to be made this time. And the other part is you also get your report also contains actual files and actual line numbers, because when you are looking at the code as well, that this particular file's line number is essentially I'm able to bypass, right, as part of my test. I can now give a screenshot of the line number and the actual file that is affected, that is causing the attack to happen. So this is that's why I'm saying that this is the best of both the worlds. There are cons to this approach as well. So access to source code is required, access to a remotely debuggable instance. That is the most important bit for remote debugging. Without that, none of this is going to really happen. You can be given an application's source code, and you can be asked to spin up an instance yourself and test it. It is never going to be as efficient as having it hosted on a pre-prod or prod environment. I mean, prod obviously you will not be given remote debuggable instance, but a lower environment like testing or some of those environments can be given to you. Obviously, the other bit is that you should have security testing as well as basic knowledge of coding. Without that, it will be impossible for you to do anything. So yeah, that's about code assisted security testing along with remote debugging, which is even better than code assisted testing. Any questions here, folks? Any question on the type of testing or why this is better, or any ideas or suggestions you have?
Sujoy, there's one question on chat. So for secure code, isn't it harmful to give source code for secure code review?
But without the source code, how will you perform a secure code review? I didn't get the question, sorry. I'm not sure if he or she is still.
Yeah, even I'm not sure if the person is still.
Probably they've dropped off, yeah. Okay, so then I'm assuming that there are no more questions, at least from the theory or the slides over here. Give me just a minute. I'll quickly try to set up. I already have it set up, but I'll try to share the other screens as well. So now is the time for demo. Now I'll try to have the remote debugging set up on VS Code and start testing and show you, how this can be a game changer essentially. So
hey, quick time check. Could you please give a heads up on how long it's going to take for the?
This shouldn't take more than 5 minutes. Yeah, shouldn't be more than 5 minutes. Sure, at the most, that is.
Okay.
So just a second. Sorry, I was talking on mute. I've shared with you 3 screens. One is the actual application that is running over here, right? So this is a Docker-based application. I mean, something that was hosted in Docker, and this is the application. It is just a very simple, bare bones. What do you say? Image sharing, sort of like a website, right? And it's not a very complex application. And here is the code that I have that is set up to have remote debugging enabled. So this is the entire file, and what I have to do essentially is that I'll have to create a launch.json file, right? Which essentially is you can go here and you can click on run and debug. So the setup that I have had to do for this thing is define this aspect of the configuration on the launch.json file, which is this is a remote attach. So the request is to attach to this port of this particular IP address, right, which is localhost. So what I've done on my Docker is that I've exposed this particular port so that this is reachable by this particular instance as well. And there are two things over here. One is the local root, one is the remote root, right? So local root essentially is this over here that you see, right? So Pixie is one, and then you have the app folder. Within the app folder is your server.js file. So this is over here, and this is what I'm telling that the folder is to be the local root. Is a remote root, which is essentially the location of that same folder in the remote instance, right, which is the Docker that we are running. Right. So once you have this set up on this side, on the Docker side, what you need to do is 1 second and just run that command. So let me just go to this Docker command. So this is I'm inside the Docker, folks, and here is the same bunch of files. So here is a server.js and everything else over here as well. And what I need to do essentially is figure out what the PID is for that particular process. So this is the process I'm interested in, and here is the PID for this. There's one step which I'm also not very clear on, but regardless, at least let you folks know what that step is, which is this step where you send a particular signal to the application process that is running, right? And based on that, once it receives a signal, there is a different mode that it goes into, which is more like a debug mode of sorts. So this is where we are right now. And the moment I hit this command, you'll see that it has enabled its debugger, right, which is running on this particular IP address port, which is localhost 9229, which is the exact same thing as the which is what we've set up over here. So we have this debugger set up and running, and we should now be able to connect to this particular instance. So if we go to run and debug, we select attach to remote. Let's see if this runs. For some reason, this is not really happening. Because once it does attach, it essentially goes into the debug mode, which is a different color and whatnot. And then I'm able to then have breakpoints installed or set up. So once I have breakpoints installed, then I can essentially see how the application is. But for some reason, it's not connecting, and there's no debug output. Okay, I think there's no time to sit and debug this particular problem. What I'll try to show is even if I did get a debug right or running, what I would show is this particular thing, folks. This is just an example of how debugging would have really helped me. So this is the server.js file for this Node.js application. So the tech stack here is Node.js in the backend, and there is a particular line number, right? So this is the line where the JWT token or the JOT token is signed. Right. So here is the function, which is the API authenticate function, which takes in these parameters, right? User object, pass object, and all the request and response, based on which if it tries to connect to the database, and then essentially what it does is checks for whether that user exists or not, and then fetches the details of that user. And once it does that, what happens is that it essentially creates a session token, right, which is a JOT token in this case. And it uses the payload. Payload essentially is the user name over here, along with the secret that exists. Okay, so the JOT signing is done with the payload, which is the name of the user, and the secret, which is a predefined secret. Now, because I have access to the source code, I can go and see what the secret is. And if I do some more searching, I'll figure out that this is the session secret. Now, this is hard coded, which in itself is a problem. But the idea is that, there is a session secret over here that is in place. Once I know this, and if I just go back to server.js, now the question is, if I have this particular this particular user object over here, and if I know the username of somebody else, I'm now able to sign somebody else's JOT token and essentially gain access to their particular session. The question is that how do I get access to this particular server.conf file, right? Because as an attacker, how will I get access to it? I have the access to source code That's the reason I'm able to get access to this particular thing. But otherwise, how would I otherwise, get access to this thing? Now, during my recon or during my manual pen test that I'll be doing, what I'll be doing is I'll be taking a look at the various endpoints that this or various URLs that this particular has. So during spidering itself, I'll take a look at this thing. And one such thing is essentially a secret thing, right? Problem over here is that there is an error that I'm getting, which has server.conf as a problem. And if I go to server.conf, I now get access to this particular file. So it's on its own, this may not be something which is very intuitive. Rather, if you have the access to the source code, you know that there's this particular sensitive file that exists over here, and you've hit the secret endpoint /secret because you've done your testing as well. This kind of combination will allow such a thing to become possible during an actual test. So on its own, if you do testing, you may not really figure out if this particular thing exists or not. At the same time, if you only have code review, you may not be able to say for sure whether an attacker will get access to this or not. And that's the reason why this kind of approach would have been very beautiful, because if I had a breakpoint setup over here when I'm trying to look at the API authentication method, then I would have come and hit this point that there is this signing that goes on over here in a very insecure manner. This is a very insecure way of signing it, because you should not use just the username and static secret to generate session tokens, because once you have the secret with you, now you can sign anybody's session token as well. So as part of my code review, I know the function definitions is over here. I would right click on it, find all references, go to where this particular method is being used. So for example, in this API.post, so in the post request of this endpoint /API user login, there is this method that is being used in this particular way, where the request object's body and the user parameter is username and the password is over here. So this is how I would be able to figure out that this vulnerability exists in that application. If I have the code also with me, if I also have the application for testing, and I have remote debugging, that would have been all the more faster and smoother for me. On its own, I'm not saying it is impossible to have come to this conclusion. It is still possible, but it would have been more complicated and more difficult. I'm sorry about the fact that the remote debugging for some reason has failed, but yeah, because also that we are out of time, I don't want to push this any further. But any questions, folks, on this before we end the session?
So will you be sharing PPT and the source, the code for this?
Yeah, I can share the code for this, but this code essentially has no meaning. It's a very dummy application, but I'll definitely share the PPT with you after this. So the PPT and the recording session both will be shared. Yeah.
Thank you.
All of you.
Yeah.
Or let's say the no. Yeah, Shiva, you have a question. Sorry, Shiva, do you have a question?
No, Sudhir, I was just about to ask, like, do we need any specific tools for doing the remote debugging, or is it like easy? I mean, straight everything.
No, typically you don't need any other tool. Most your languages have a method of having remote debugging enabled. Some of them differ from each other, but they're more or less standard how you do it. So your IDE should, something like VS Code, IntelliJ, they all have the capability of attaching to a remote process and running this thing. So this is not really something that is very complicated, or you don't need any special tools for this. No.
Thank you, Sudhir.
Okay.